Assalamu alaikum. Welcome to my video series on data science. Today we are going to start step number 6 of data science process, that is machine learning modeling. In this session, we will learn what is machine learning and its types and differentiate it with the traditional programming approach. In the coming lectures, we will explore different classification, regression and clustering algorithms. So what is machine learning? According to Tom Mitchell, a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P. If its performance at task T as measured by P improves with experience E, then we call it machine learning. This was a bookish definition. In simple words, machine learning is a field of artificial intelligence that gives computers the ability to learn without being explicitly programmed. By feeding machines with data, we enable them to identify patterns, make predictions, and take decisions. Let's differentiate traditional programming with machine learning. In traditional programming, the programmer writes explicit codes, rules, and instructions, while in machine learning, the algorithm learns from the data. Traditional programming relies on human expertise, while machine learning algorithms adapts to new data and improves over time. Traditional programming is limited to specific tasks, while machine learning can handle multiple complex tasks. There are two common types of machine learning: supervised and unsupervised. To understand them, we first need to learn the difference between labeled and unlabeled data. So if your dataset contains examples along with the class labels, this is known as labeled data. For example, you can see here we have different fruits and each fruit has a corresponding label. Supervised learning algorithms use labeled data. On the other hand, if we only have the training examples with no class labels, then this is called unlabeled data. We can see that in the example where we have different fruits but they do not have any label. So we use unsupervised learning methods when we have unlabeled data. In supervised learning, if we are going to predict a numerical continuous value, then we call it regression. For example, predicting house prices, predicting students' marks, and so on. If we are going to predict discrete class label, then we call it classification. For example, predicting if an email is spam or not, predicting that if a transaction is fraudulent or not, etc. In unsupervised learning, the common techniques are clustering and dimensionality reduction. Clustering groups the data points together based on the similarities and differences, while dimensionality reduction reduces the number of features in a dataset. We have already discussed the dimensionality reduction part in data transformation section. Let's discuss machine learning workflow. So we start with the dataset and then we pre-process it and prepare it for the machine learning model. So in our data science course, we learn different techniques to pre-process and clean the data and transform it so that it is digestible by the machine learning model. So once the data is ready for machine learning modeling, we split the data into two parts: training data and testing data. Then the next step is to choose a suitable machine learning algorithm. So once we choose a machine learning algorithm, we give the training data to that algorithm so that it learns patterns from it. So once the model is trained on the training set of data, then we use the testing data set to evaluate the model's performance on unseen data. And this is an iterative process. There are several machine learning algorithms, and I have listed here a few of them. Commonly used regression algorithms include simple and multiple linear regression and polynomial regression for non-linear data. Classification algorithms include logistic regression, k-nearest neighbors, neural network, support vector machines, decision trees, and so many others. Common clustering methods include k-means clustering and its variants, k-midwight, agglomerative clustering, dbScan, etc. We have already explored principal component analysis in dimensionality reduction. There are other several algorithms For example, single value decomposition (SVD), linear discriminant analysis (LDA), and so on. So the most important part in machine learning is choosing an appropriate machine learning algorithm for your data and problem. So I have taken this diagram from scikit-learn website, which showcases the key workflow of choosing an appropriate machine learning model for your problem. So the first step is to check whether you are predicting a numerical value or a categorical value. If you are predicting a categorical value and the data is labeled, then you will go for classification. If you are predicting a categorical value and data is unlabeled, then you will go for clustering algorithms. But if you are interested in predicting a numerical continuous value, then you will go for regression algorithms. And if you are not interested in predicting a quantity but a structure, then you will choose dimensionality reduction algorithms. So in today's session, we learned what is machine learning, how it is different from traditional programming approach, what are different types of machine learning. We learn about supervised and unsupervised learning. In the next session, we will start with the regression algorithms. If you found this video helpful, don't forget to like, share and subscribe for more videos on data science and AI. See you next time.